What's up, people? Welcome back for the subject of computer networks. Here we are going to learn the topic digital modulation and multiplexing. So let's begin. We have an introduction to digital modulation and multiplexing. So, the digital modulation and multiplexing are essential techniques in computer networks for transmitting and receiving data efficiently and effectively. These involve the process of varying one or more properties of periodic waveform known as the carrier signal with a modulating signal which contains the messaged data. Multiplexing allows for multiple signals to be combined into a single signal over a shared medium, optimizing the use of available computer resources. Now, next one are the basic digital modulation techniques. These techniques are at the core of modern communication systems. This involves encoding of digital information into analog signals for transmission, allowing efficient transfers over various communication channels. One of the fundamental techniques are amplitude shift keying, where amplitude carrier signal is modified into digital data, and similarly to that we have frequency shift keying and phase shift keying, which alter the frequency and phase of the carrier signals respectively into their digital information. These modern techniques play a crucial role in ensuring reliable and accurate transmission of digital data, especially in wireless communicating systems and networking. Now let's learn some multiplexing techniques in computer networks. First one is a time division multiplexing. This is a technique used for transmit of multiple data streams over a single communication channel, where the channel is divided into time slots where each data stream occupies an allotted slot. This allows for multiple signals to be transmitted at a time and increases the overall efficiency of the communication. Next one is frequency division multiplexing, which is a method for transmitting multiple signals over a shared communication medium, which allocates each signal in a different frequency bandwidth within the medium. It allows for different signals to coexist without interfering with each other, making an efficient use of available bandwidth. Let's learn about the baseband transmission. Now let's learn what are signal transmission. This involves direct transmission of data signals without any modulation over a single channel. The digital data sent here without any conversion of analog form makes suitable for applications such as LANs, where the efficient use of bandwidth is done along with commonly used data communication over short distances. Next one is signal encoding. Before transmitting of any data through a baseband transmission, it is very crucial to encode the digital signal to ensure its integrity and reliability. Techniques such as Manchester encoding, differential encoding, and non-return to zero encoding are commonly employed for signal encoding to mitigate data loss and errors. Now, what's the advantage of using baseband transmission? Here, it allows to inherit simplicity in signal processing and signal transmission, which makes it suitable for applications which require a straightforward and cost-effective communication. It also allows for straightforward use of digital switches and provides a clear path for data transmission without a need for carrier frequencies. Now next one is the balanced signals. In the context of digital communication, a balanced signal refers to the transmission of an equal and opposite signal voltage. It ensures that the net direct current or DC component in the transmission medium is zero, which is very essential especially for reliable data transmission and noise immunity. Some common Applications of balanced signals include the twisted pair cables, which can along with widely usage in LAN networks and telecommunications. Next one are the advantages of balanced signals. One key advantage is that they their ability to reject the common mode interface, which means that any noise or interface which is picked up along the transmission path is cancelled out, resulting in a cleaner and more accurate signal reception. Next one is passband transmission. This refers to the process of modulating any digital signal onto a carrier frequency for transmitting over a communication channel. Here, the technique is very essential for enabling the efficient and robust transfer of data through various communication mediums, which include the wired and wireless networks. One such aspect of passband transmission is that it converts the baseband signal to passband signal through modulating techniques such as amplitude modulation, frequency modulation, and phase modulation. These modulation methods enable for encoding of digital information onto the carrier wave, allowing for efficient transmitting of data. In addition to modulation, this transmission also involves the use of various encoding and multiplexing techniques to optimize the utilization available in the bandwidth. It ensures reliable data transfer, and this is crucial for students to understand the computer networks as a form of foundation for the design and implementation of communication systems. Next one is baseband transmission. Here, first one we are going to learn of is signal encoding, which converts the digital data into a digital signal. Next one is the line coding, which maps the digital bits into digital signals. And lastly is baseband modulation, directly transmits digital signal without any modulation of a carrier. Now, this involves the transmission of digital signal without modulation or conversion to a different frequency range. And so, it involves the conversion of digital data into digital signals and line encoding, which maps digital bits into digital signals. Now, why it is important? Now, it is important that this is a crucial field of study in the digital communications and computer networks. Next is time division multiplexing. The time division multiplexing, or TDM, is a communication process where transmits multiple data streams over a shared channel by assisting each stream into different time slot in a round robin fashion. It allows multiple signals to be transmitted simultaneously over a single transmission medium. How it works is that a single data stream is allocated a specific time interval in which it can transmit its signal. The time slots are then arranged sequentially, and the process of allocating and transmitting of data is repeated in a continuous cycle. Now, it prevalent in telecommunication systems and digital audio broadcasting. Now, what are the advantages? It allows for each data stream to receive an equal share of total transmission capacity, which prevents any stream from monopolizing the channel. It also allows for efficient use of bandwidth by utilizing time slots efficiently. And the final topic for today's video is the frequency division multiplexing. The FDM is a technique used for combination of multiple analog signals onto a single transmission medium by assigning each signal a different frequency. It allows for simultaneous transmission of multiple signals without actually interfering, using its unique frequency allocation. Now, next is bandwidth division. Here, each signal is allocated its specific frequency band within a transmission medium, which allows that each band to depend on the characteristic of the signal being transmitted, and the total bandwidth is divided to accommodate the signals being multiplied. Next is the implementation of these in telecommunication systems. FDM used in telecommunication systems usually combine telephone channels, television channels, and other data streams onto a single transmission medium, such as an optical fiber, within the electromagnetic spectrum, which allows for the efficient use of available bandwidth. This is the end of the video, guys. I hope you like it, and you can comment your thoughts in the comment section below. Thank you.